Hi, this is Dr. Jenny, and this is a continuation of problem 6.3. We're in section C, we're in part C, section 5. In section 5, they ask us to use our model, the third model, or the III model, to predict the average fare on a route with the following characteristics. And so you see that they have coupon, new, vacation, and essentially what we're going to do is apply our y equals a plus the bx, cx, dx, and so on. So I'm going to go to the calculations so that we can see what we have here. And if you notice, this leaves us the coupon, vacation, all these different variables, but we don't have new. This is the model that's III. If I go here and look at the training lift chart, which was produced when I did the multiple linear regression, this is a copy of the chart when I did the one that compared the two together. And essentially, if I want to go back to the navigator here, I just go back and it takes us back to this so that we can see it. And we have both a training and a validation lift chart that we could review. And then this tells us all the things that we did down here, so that we see that our output variable will be fare, and all of these are input variables. This was a 12 number, this was our best subset of 12, and then you'll see here these were the output options that I chose when I did the multiple linear regression. You can also choose lift charts. If you didn't do it on the first time when you were doing them, you can go back and redo it. You'll just have to make sure you know which of your final outputs is the one you want to use. Now what happens down here, this is the regression model. So the constant term is like A. Then this would be all the variables in there. Remember that my formula is y equals A, well it's little a, plus bx plus cx plus dx, and so on. So that's my formula, and so this is my A, this will be my B, C, and so on. So this is how I'm putting this formula together. This is the coefficients. So eventually, these are the things that I use to plug into this model, y equals a plus bx, cx, and so on. So you'll see that over here that I've repeated them. So let me highlight those so you know what I'm talking about. Probably shouldn't use yellow. Let me use blue. And didn't need to make that red. So now I have blue over here. I'll put a blue over here so you can see that I just pulled these over here. Then what I did here, this is essentially, this is the information they gave us in the textbook to use. Now I think it's kind of odd that we ended up having new in that, and we didn't use it. But you know, that's just part of what we would have. And in fact, let me bring over the Excel or the PowerPoint slide here. And I've lost my PowerPoint wherever it went. Let me pull it up again. Okay, this is showing you that if I had put new in there, even if I had a zero coefficient or had a coefficient here, and I don't, in the 12 predictor model we didn't use new, so then it's just zero across. And so you'll see that I have and basically in my PowerPoint I'm 2 cents difference, and it may be something to do with random or my typing skills, but anyway, I've brought over these these coefficients, and then I plugged in the sample that was given to us in the textbook. And so what they're doing is here using this model then to predict the fare. Now the actual answer is 253.44, not 46, and I'm not quite sure what I did differently, but maybe it's because I carried something out, I don't know. But all I did here then was, here's this number here, and I just took the coefficient times the number that they gave us. You can see by my formula up here, that's all I did. And then I just copied this down. whatever the formula was, whether it was negative or what, because remember, it can be negatively correlated and still help us with the prediction. And this is telling me that I have about a 79, almost 80%, well, I guess it's 79% R squared here. So I do have, some error that would be result from this prediction fair. But again, if you go back and look at this lift chart, you can see that the predicted values here in the blue are not that far from the cumulative error using the average. So really, this is a pretty good predictor that we have there, and that is a good R squared. Remember, the closer to 1, the better. So this is really not a bad prediction in using this fair. Now I'm going to stop here and we'll go into the next Jing for the next section.